Okay, so here I'm going to take you through a full U value question. This is last year's exam, 2019, question 5. It's on page 33 of your books, of your exam papers as well. Alright, the way it worked out last year was quite manageable. It was all calculations, there was no notes part of the question. They gave a cavity wall. Part A, calculate the U value. Part B, calculate the heat loss. And part C was calculate the amount of insulation needed to get to a certain U value. So your three types of calculations as I've shown over the last couple of classes. So I'll start with part A. We'll go through every single step of the question. Before I start the question, I would recommend that you actually sit down yourself and try and attempt a question before you look at this video, so that you can actually start getting to the level where you're doing it by yourself. Any problems you hit, or if you want to just double check anything, then maybe sit down and watch the video afterwards. Alright, so we'll read part A first of all. The external wall of a house built in the 1990s is of 100mm concrete block construction with a 100mm partially filled cavity as shown. This is a wall that we've drawn loads of times before in our details. So we have a basically cavity wall with a bit of insulation in the middle. You can see a sketch there which will help, and you also have your list of layers involved with this, and also your thermal data is down there as well. So going straight into that question, having read that, the first thing that you should do is do a sketch of the wall we're dealing with. So up here we have a sketch, so if you just focus on that part first of all. We have 1, 2, 3, 4, 5, 6 layers to be dealing with, plus your external surface, the invisible external surface, and your invisible internal surface. So that's going to make it 8 layers we're dealing with. External render, external block, cavity, insulation, internal block, internal plaster. Okay, at that point then you will go on and you would draw up your table. This table here, just for the sake of time, I've drawn up already. All your layers are there. I've worked from the outside in. There's your invisible external surface, there's your invisible internal surface, and everything else is drawn in, working from there across to there. All of this information is what is given to us in the question. So it's just a matter of drawing up your table, which you need to know how to do yourself, and then inputting the information. As we know, the question is going to give the thicknesses. That's going to be given as 16mm, 100mm, 50mm, 50mm, 112, and when you put those into meters, that's what they should look like. Also, the question, just something to watch out for, some of the situations they gave resistivity, some of the situations they gave conductivity. Make sure you put these things in the right columns. Now, at that point then, as we all know at this stage, we just have to find our resistance. It's always all about finding resistance. For the external surface and the internal surface, they gave us resistance, but also for the cavity, they gave us the resistance. The cavity is just air, so things that you can't really calculate thickness for. I know there's 15mm for the cavity, but it's air you're dealing with. They usually just give you the full resistance. So we have full resistance for those. We need to calculate this, 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 and this. Something else maybe just to watch out for. We have an external block and an internal block. Both of those have the same conductivity. Both of those have the same thickness. Sometimes in a question, it might just give the information as block work. So for example, here it has said concrete block outer leaf 100mm, concrete block inner leaf 100mm. We have done a question in the past where instead of having 2 of those, it'll just say block work 100mm. You're supposed to know there's 2 layers of block work, and you must put that in twice. Watch out for that. So, calculator out. We have our 2 formula up here to calculate resistance. So we have here this multiplied by this first of all. So to get the external render, it's 2.170 multiplied by 0.016. That gives us 0.034. We'll go for 3 decimal places. 0.034. This one here, it's T over K, so it's T divided by K. So it's 0.100 divided by 1.440. That gives us 0.069. That is also going to be the same for the internal block layer because it's the same numbers you're dealing with. So we're going to put that in 0.069. T over K here. So we have 0.050 divided by 0.037. That gives us 1.351. That's a relatively high number compared to the rest because insulation would have a good resistance. And here we're back down to resistivity and thickness, so we're multiplying this by this. 6.250 multiplied by 0.012. That gives us 0.075. Now it's just a case of adding up all these numbers, being extra careful to make sure you get your numbers right and your decimal place is right. Very easy to make mistakes here. So 0.048 plus 0.034 plus 0.069 plus 0.170 plus 1.351 plus 0.069 plus 0.075 plus 0.122. Okay, now no harm in just kind of sitting and having a look at all those numbers again and comparing them to what you have on your calculator. And once you're happy enough, your total resistance equals 1.938. Okay, now once we have our total resistance, so our U value equals 1 over your total resistance, RT, so that equals 1 over 1.938. Calculator out again. So 1 divided by 1.938, and that gives us a U value of 0.515. 0.515. Alright, that's part A done. We're going to move on now to part B. So I'll have a quick look at it. We'll read it. Using the U value of the wall obtained at 5A, which we just got above, and the following data, calculate the cost of heat loss annually through the wall. So again, we're going to the second calculation that we learned before. We need to figure out how much heat is lost through this wall and how much that's going to cost in the amount of oil that you need to supply it. The information is all here. We have the area, the temperature difference, the heating period, the cost of oil, the calorific value, and it just tells us 1000 watts is 1 kilojoules per second. Most of that information we'll need. A lot of it you might understand what it means, but it's just a matter of going through the 5 steps that we've spoken about time and time again. So we'll just go on to part B of the question straight away. Now, step 1, maybe it's no harm just to write your U value that you obtained. Again, if that U value is incorrect and you carry it forward, you'll still get your full marks if you carry out these steps correctly. Now, step 1, it's from our notes, we know it's U value multiplied by area multiplied by temperature difference. If you want to write that down, you can. If you know it off by heart, you can just go straight into the numbers. Multiplied by area is 135. And the temperature difference, let me just look at that right. Area is here, 135. Temperature difference with internal temperature 19, external temperature 5. So 19 minus 5 will give us 14. So calculator again. 0.515 multiplied by 135 multiplied by 14 equals 973.35. Be no harm underlining that. Step 2, you need to find the amount of seconds that the heating is on throughout the year. So that is the weeks in the year, the days in a week, the hours in a day, the minutes in an hour, and the seconds in a minute. If you want to write that out here, you can. If you want to just go and write that out without off by heart, you can go and do it. So it works out 37 by 7 by 9 by 60 by 60. Now, where does that information come from? 36 weeks. So the heating in this particular house is on for 36 weeks in a full year. That tells us here 36 weeks per annum. Annum means a year. Obviously it's not on all year long because summertime they won't be using the heating. 7 days a week. It doesn't say how many days, so common sense will tell us we go by 7 days a week. Go back to the question. It says here 9 hours a day. So you get your 9 hours a day. And common sense will tell us there's 60 minutes in an hour and 60 seconds in a minute. So you just get all those and you multiply those out. So 36 by 7 by 9 by 60 by 60 equals that 8164800. Again, that's your answer for step 2. That's the amount of seconds the heating is on that house for a full year. Now, step 3, it's basically multiply this by this. All right, if you want to write down what you're doing, you can, but in an exam situation, all you have to do is 973.35 multiplied by 8164800. Now that all must be also divided by 1000. So 973.35 multiplied by 8164800. Double check that. Equals there, big number, divided by 1000. And we get 947,208.08. 7,947,208.08. Now, step 4, it's a case of calculating how much litres are needed. So step 4, that's the amount of oil. Okay, so it's the amount of oil divided by the calorific value of the oil. So it's basically 7,947,208.08 divided by the calorific value of the oil, which is 37350. Take our calculator. 7,947,208.08 divided by 37350. That gives us 212.77 litres. 212. Okay, again you can underline that. That is your answer for step 4. And now all we have to do is calculate how much those litres are going to cost you for heating that wall. So we just go on to step 5. We get our 212.77. And we multiply that by the cost of oil, which the question tells us is 94 cents per litre. Remember, watch out, 94 cents is 0.94. So, last calculation here, 212.77 multiplied by 0.94 equals 200.0038. That'll just work out €200. So to heat that wall for that particular year, it's a matter of paying just €200. Part B done. Okay. Now, part C, we're going to go straight on to. These calculations are new to us. Again, with a bit of practice, it gets quite straightforward and easy. Let's just read it first of all. It is proposed to upgrade the thermal properties of the above wall to meet the passive house standard by fixing expanded polystyrene to the external surface as shown. What it's saying there is we want to stick some insulation to the outside of the house just to make it a better standard of wall. Given the thermal conductivity of expanded polystyrene is 0.031, calculate the thickness of expanded polystyrene required to achieve a U value of 0.15. So they want to know how much insulation they must stick to this wall to get to 0.15. Alright, so what we need to do here is carry out the steps that we've carried out for this kind of a calculation. It's basically retrofitting the house. So existing U value. The existing U value is the U value of the house that we got in part A, and that U value that we got in part A is 0.515. So the existing U value is 0.515. Next we want to get the existing resistance. Again, all you have to do is go back to the table. The existing resistance is 1.938. So we'll use that. 1.938. Okay, if those numbers are incorrect, if you calculate those wrongly, you can still carry them forward, and if you do this right, you get your marks there. Now, the required U value. The question tells us they want to get this U value lower. 0.515 must come down to 0.15. Alright, that means we need to find how much resistance there need to be. Okay, we're working backwards, so there's our required U value. If we want to find how much resistance we get, we do 1 over 0.15. So that is 1 divided by 0.15, 6.666. That's quite a high resistance for a wall, and obviously it's a passive standard we're trying to get to, therefore it's such a high resistance. So that's the original resistance. We need to bring that resistance up to here, and by adding insulation it's going to make the wall more resistant. So we need to figure out how much more resistance is needed, so we take this away from this. So 6.666 minus 1.938. That will give us a result. We'll do it. Okay, so 6.666 minus 1.938. That gives us 4.728. So the extra layer of insulation that we're adding to this wall must have a resistance of 4.728, which will add on to the existing resistance, which will give us this full resistance here. Okay, so at this point then we have to draw up a quick table. So element, conductivity, and resistance. Now, this table is just for that new bit of insulation. The resistance we want the insulation to have is 4.728. I'll just fill in insulation here. The resistivity is not given to us, we don't need it. The conductivity of the insulation that is being used is 0.031. Okay, we need to find the thickness. So if we use my formula, the TKR triangle, it's kind of triangular in shape. If I want to find thickness, it's K by R. If I want to find conductivity, it's T over K. If I want to find resistance, it's T over K. Sorry, that's T over R for that. Okay, so we're looking for thickness, so it works out with K by R. So that's going to be 0.031 multiplied by 4.728. So 0.031 multiplied by 4.728, and that will give us an answer of, we'll do 3 decimal places, so 0.146. 146. That's your size, the thickness. That's in meters, so that will work out at 146 millimeters of insulation is needed there. So that is the full question complete. Quite a manageable question.